I wanted to give an update on the band stacking project that I've been working on. And so I thought it'd be cool to share the band stacking outputs as basically like as they look like in QGIS. So I think in my last video, I went into depth on like kind of how I came to the how I worked through the steps of generating the program itself, but I wanted to just maybe make a quicker video just showing the output and then a summary of the components of the program that Claude helped me generate to get to this output. So here's what the band stack looks like in QGIS. I made an RGB composite. If you're not familiar with playing around in QGIS, if you right click on a layer after you brought it in, so I guess I could show that first. If you go to layer, create layer, or actually add layer, go to raster layer, this is where you add the layer in. When it comes in, it might look a little discolored. So if I right click on the layer itself and go to properties, this is where I can select a band combination that will make it an RGB composite. I changed the like the reflectance units to be between like 0 and 65,000 because that's how MicaSense cameras typically present themselves after you processed it in Metashape or Pix4D. But I haven't even looked at the histogram yet, but yeah, it looks a little weird. Let's see. Okay, you can see it. They're basically floating between 0 and 10,000, all the values between band 1 and band 6. So that's looking kind of normal. I'm a little curious as to why the peaks are so low. Typically, those peaks are higher, but maybe not. You can kind of see them there. But yeah, so this is the output. I actually ran two different programs. One of them was like the original band stacking, and then I just asked Claude, is there a way we can make this even more precise from a pixel level alignment? And it did something that I'll cover here in a minute with a screen sharing from the Jetson to show you what the components of that additional pixel alignment process look like. But here, if I zoom in here, you can see, so this was the refined, and this was the unrefined, like initial program. But it basically fixes a misalignment. The refined version that I made fixes a slight misalignment on the near infrared and the red bands. So I'm looking at the RGB composite here, and you can see these red pixels showing up. But if I uncheck the original and look at the refined version, you can see that that's been shifted over a little bit. So it's making the pixel level alignment even better than it was originally, which is important for people who are doing vegetation analysis so that they can have higher confidence that the pixels they're getting are corresponding to what they're seeing on the ground. And we can see that even clearer. I can see that even clearer if I change the composite to something else. So if I go up to symbology and let's do like a 5, 4, 3 composite. So this would be near infrared, red edge, and red. And I'll apply that. And then I'll do the same thing to the original version so we can compare apples to apples. And you can see it's a pretty significant shift in pixels because now we're looking at near infrared and red in that false color composite, not just red. So if we look at a plant itself, let's see the shift. And this is a little bright. So you can see more red pixels are showing up in the stack, and then it's shifting to be more aligned. But we could darken this up so it looks a little better by just adding let's do 15,000 to the max. So this is going to let in more values and darken the image a little bit. Yeah, there you can see that the refined version is quite a bit better. So this is unrefined, and you can see those kind of fringing of red coloring. And then when I click the refined, it shifts and gets more aligned. So I'm going to shift over to the Jetson screen sharing to show you the output, or kind of like what made the program, so that maybe you can replicate it yourself. So this is kind of like the workflow for creating the program. So the TIFF file goes in, the panel calibration image goes in. The first step is a radiometric calibration, and it's correcting the digital numbers to physical reflectance based on the calibration panel. I pointed, as I mentioned in the previous video, I pointed Claude to MicroSense GitHub a number of times to get this to work right. I had to do some finagling to make it collect the panel and not the ground or a bad part of the panel. Then I ran, there's a per band distortion model, lens undistortion to like get rid of the vignetting and other things like that. Again, I'm not super technical, so I might be butchering some of this, but there's a rig warp from rig relatives. This basically, the 5 different bands of the RedEdge camera. There's an offset, and then there's like a control band, which I think is the green band. It's the reference band, and so this pulls the rig relatives from the metadata and allows the bands to be aligned to create the stack. And then after that, there's a SIFT alignment, a feature match refine that basically takes the rig relative alignment and improves upon that. And then there's a crop that gets rid of the edges that aren't common across all 5 spectral bands. And so that brings the total size of the stack down to 84% of the original raw file size. And then I added georeferencing data so that when I open it in QGIS, it puts it on an approximate location of where the image was captured. And then I also added flight heading so that the image is rotated correctly, which is going to be important when we try to do the mosaicing later on. And then I think the final step was turning it into a 16-bit package, reflectance times 32,768, and then a single page 5 band that can open in QGIS. So that was program A, the band stack, taking images from raw captures to the stack, the geotiff essentially, the 5 band geotiff. And then I made a program B, or I had Claude make a program B more correctly, that takes those stacks and refines them. I mentioned earlier in the video that the red band and the near infrared band were not super well aligned. And so this basically takes the green reference, the green, the blue, green, and red edge, which were really good on alignment, and it makes those sort of the reference bands, and then it fixes this red and near infrared misregistration. And let's see, it took the red from I think this is on like pixel alignment from like 0.72 off to 0.25 off, and the near infrared 1 off to 0.31 pixels off. So it improved it quite a bit. Yeah, so it took the original band stacks and it refined them, made them more aligned. And as you saw in the beginning of the video, the outputs are pretty solid. So still working on the mosaicing. It's proving to be very tricky. But hopefully I'll be making progress on that and I can share in the next video.